we have talked about the volume of prisms and pyramids. The volume of prisms and pyramids is the amount that these shapes hold. We are going to move to finding the surface area of prisms and pyramids. The surface area is if you were going to wrap the shapes in wrapping paper or cloth or tape or paint them, but it's the outside of boxes. So to find the surface area, it's very much similar to composite figures. And if you remember composite figures, it was taking simple two-dimensional shapes like rectangles and triangles and circles and putting them together to build an unusual shape. But you knew how to find the area of a rectangle. You knew how to find the area of a triangle, and you knew how to find the area of a circle. So finding the surface area of prisms and pyramids is not much different than a composite figure. If you notice with the example that they give us, you can see that there's just a bunch of rectangles. As a matter of fact, there is 6 rectangles. You have the 4 in the middle that make up the lateral surface area. So if I highlight the lateral surface area, we will use, let's use blue for the lateral surface area. So if I highlight the lateral surface area is the walls. It's basically the sides. So the lateral does not include the bases, okay? It's all the sides except for the bases. If we look at the total surface area, the total surface area includes all of it. It's going to include every piece, finding the area of the whole thing. But what we try to do is break it down into shapes that we recognize. So we want to try to find the lateral surface area first, which is the area of the shape without the bases. And then we will find the area of the bases and add them together. Do we have any questions at this time about finding the lateral surface area? So example number 1 says determine the total surface area of the rectangular prism. So total surface area means we are going to be finding the area, the lateral surface area, plus the bases, and together it will give us the total surface area. I use acronyms for lateral surface area and total surface area because it could get a pretty lengthy sentence if we were to use the whole word. So I'm going to go ahead and I'm going to highlight the lateral surface area in blue, which is what we did up top in the example. So what I actually try to do is find the area of this rectangle here. Now, most of the times, your problems will tell you which ones the bases are, especially if they ask you to find the lateral surface area. So I'm going to go ahead and label the bases. And then I want you to recognize that I highlighted this entire rectangle right here in the middle. Yes, it is made up of 4 different rectangles, but what I like to do is find the length going all the way across it, okay? So I just want to use 2 dimensions of the length and the width. So if I find the length going all the way across, I recognize that these two are the same. So if this side over here on the right is 8, then this one over here is 8. And so I can tell that the length going all the way across is going to be, was that 6, 6 is 12, 12 plus 14, or 12 plus 16 is 28. So the total length of the lateral surface area is 26. Right here, we can tell that the width is 7. So I know that my lateral surface area is 7 times 26, because that is how we find the area of a rectangle. And then my bases. I recognize that my bases, there are two congruent bases. In rectangular prisms and triangular prisms, you have both the top and the bottom that are congruent or the same. So the bases I see, remember they are congruent, so they have the same dimensions. This one is going to be exactly like this one. So if 6 times 8 on this one is 48, then I know both of them are 48. Now, I have two of them, so I'm going to multiply 48 times 2. And now I will combine the lateral surface area and the area of the bases to get my total surface area. The lateral surface area is 7 times 26. You are correct. It is 182. Plus the area of the bases, which is 48 times 2. It is 96. And I combine these for the total surface area. Very good. It is 278 meters squared. Now, we are talking about area, and area is two-dimensional. So you will have the exponent of 2 to represent that it is a two-dimensional shape. Do we have any questions about finding the total surface area of this rectangular prism? Let's take a look at number 2. Antoine is wrapping a block of cheese that is 22 centimeters long by 6 centimeters high by 10 centimeters wide with plastic wrap. How many square centimeters of wrap are required to cover the cheese? Now, I do recognize that they do have the bases labeled where I would normally like to put my lateral surface area. But I noticed that with the question, it appears that it's going to be asking me for the total surface area. So I want to make a note of that. Total surface area was in green, so I want to make a note that it's wanting the total surface area. And to calculate the total surface area, remember we need to find the lateral surface area plus the bases to give us the total surface area. So because I want total surface area, I know that it does not matter what order I add all these up in. All I want is to make sure I get the area of all the shapes combined. So even though it does tell me that these two are the bases, I'm going to go ahead and simplify this for myself and include this in this rectangle right here, the one that I would normally call the lateral surface area. I am going to say, again, I know it says base, but for the sake of solving this problem, because I want total surface area, I'm going to go ahead and just find the area of 3 different shapes. Now, there is something that I also want you to recognize, is that you do have the two bases, right? So the two bases are going to be the same. Then the other two parallel sides will be congruent as well. And then these two will be congruent too. So I can make a note of that real quick. Let me see if I can change. So I know that the two bases are the same. I know that the small one here, I might call it the, I don't know, the left and the right, and the top and the bottom maybe. We will do that. So the left and the right are going to be the same. And then the top and the bottom are going to be the same. Now, I also want you to know that when you're closing up a box, that since this is 6, this needs to be 6. Because they will close on each other and be the same length. And I already told you that this one here on the left is going to be the same one on the right. So if this part is 6, then we know this is a length of 6, and this is a length of 6. You're going to have to make sure that you go through and you identify the lengths of all these little pieces in the rectangles. I also want you to see that there's another piece of this where the two bases are the same. So if I know these are 10 centimeters, then this is also 10 centimeters. I am actually going to change that because I want to use lines of congruency instead. So let's draw this back. We're going to find the area of this first. I know these are the same. These are congruent lines. So we have this side is congruent with this side, so I'm using lines of congruency. I know that these two sides are congruent, so I'm using lines of congruency. I also know that this width is the same as this width, so I'm using those lines of congruency to note that they are the same as well. So now I can find the length going all the way across. I know that it's 10, 6, 10, and 6. Yeah, 10, 20 plus 12 is 32. So I know that this going all the way across is going to be 32 centimeters. Our width right here is 22. So it looks like my lateral surface area has dimensions of 32 times 22. And my bases, it looks like they're going to have dimensions of 10 and 6. They are both have the area of 60. So I'm going to add 60 times 2. So I have my lateral surface area, which is 32 times 22. It is 704. The area of the bases is 120. And when I combine these together, I get the total surface area of 824 centimeters squared. Again, I know that we talked about the bases being labeled, and although this piece in the center does have the bases, I wasn't too concerned about this because I wanted to make it a simpler problem for myself and just find the area of the one big rectangle in the middle, and then I found the area of the two, for a lack of better terms, wings. So with this, I'm able to find the lateral surface area. I was able to find the area of the bases. The lateral surface area plus the area of the bases does give me the total surface area. Do we have any questions at this time? Let's take a look at example number 3. Example number 3 says, what is the lateral surface area of the rectangular prism below? So I do recognize that this one is asking for the lateral surface area only. And I know that I told you that typically the bases are going to be labeled, so I'm going to go ahead and label them for you. I'm going to make these the bases. And I'm going to highlight the big rectangle in the center so we know that this is just the lateral surface area. Again, I like to find the length going all the way across. So we have, let's see, 4, 6, 4, and I think that's supposed to be 6. So we have 10 and 10 is 20, so the length of this one is 20. It has a width of 12. So I know the lateral surface area is a 20 by 12, which is an area of 240 inches squared. Remember, when you're looking for lateral surface area only, you do not need the bases, just the large rectangle in the center. Do you have any questions at this time? Number 4 says, what is the lateral surface area of the rectangular prism below? So again, this one is asking for the lateral surface area. So I'm going to highlight the large rectangle in the center. And once again, it will usually have the bases labeled for you. But we do not need the bases because we're only looking for lateral. So find the length of the whole rectangle. 10 and 10 is 20, plus 4 and 4 is 8. So it's 28. And then the height of 17. So the lateral surface area is 28 times 17. Which is 476 centimeters squared. It is squared because it is a two-dimensional shape. Do we have any questions about finding the lateral surface area at this time? Let's try the last one in our notes, number 5. Number 5 says, Iker is painting his bedroom that measures 12 feet long, 10 feet wide, and 7 feet high. He has 1 gallon of paint that covers about 350 square feet of surface. Does he have enough to paint the lateral surface area of his room with 2 coats of paint? So we're only wanting the lateral surface area. So I'm going to go ahead and highlight that. The lateral surface area. But there's a little tricky piece in here that it says it wants 2 coats of paint. So this makes me think that we are doing the lateral surface area times 2. So again, I'm going to highlight the lateral surface area of the bedroom because we don't need the ceiling or the floor. It looks like going all the way across that we have 10 and 10 is 20 plus 24 is going to be 44 feet long and 77 feet high. So my lateral surface area is 44 times 7, which is 308 feet squared. Now, it does say that he wants 2 coats of paint, so I think we're going to have to do this twice. I'm going to multiply it by 2. So he's actually going to be covering 616 feet squared because it's 2 coats. So would 1 gallon of paint cover that covers 350 square feet be enough? And I would say no. 350 is less than 616. Therefore, 1 gallon is not enough. Do we have any questions at this time for finding total surface area or lateral surface area?